my channel, STEM Cafe, where I make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertain. Today, I want us to handle basics of current electricity. When we are talking about current electricity, there are three main things we consider: voltage, current, and resistance. Voltage, current, and resistance. Voltage is just like pressure, potential difference. That is determinant of the flow of current. But resistance is just like the tap, like the controller, or like the passage. So because we call it resistance, it must have given us the idea that it is just like an hindrance to the flow of current. Current is flow of electrons or any charge. That is why we have it like this. And there is a relationship between this, and this. Resistance is equal to voltage over current. The unit of resistance is ohm. And the symbol is this. Voltage. And represented by this. Current is ampere. We represent by this. So, with this, we now know that we can have current, resistance attached, because resistors are physical quantities that we can handle. This one and this one, they are not visible to the eyes, but we experience the flow of this one, and this one is determinant of the flow. We experience the flow of this. That's why you see electrical bulbs light on, iron gets hot, and fan rotates. What I'm concerned about now is addition of resistance. Addition of resistance. With this, it must be understood. That is the basics. Main basic of current electricity. How to add resistors. We mainly have it in series and in parallel. Now let's look at how it is in series. Now we are talking about resistance in series. For this, we have V from here to here. We call it VAB. And the current will flow like this. It will get to this place, then get to this place, then get to this place. You can see this VAB covers the whole place. So we have V1 here, we have V2 here, and V3 here. And if you look at it, the power, the total power here will exit here. That is why we have it like this. So with this, because of this, I will flow. That is current. I will come here. It will come here. It will come here. Because the whole I that comes here will exit at this place. No branching. That is why we can look at it and say, okay, VAB is equal to V1 plus V2 plus V3. This is very important. It's not just about the formula. The understanding of what takes place here is very crucial. Now, VAB now will be equal to I, because I is the same thing, R1 plus I, R2 plus I, R3. But I said initially, the I that comes here is one that exits here. So, the effective resistance, that's what we are calculating, the effective resistance. Let the effective resistance be R. So, we can now say I VAB is equal to I R. V is equal to I R1 plus I R2 plus I R3. Dividing through by I, because I is the same one. You can now say R is equal to R1 plus R2 plus R3. Now, we can now make some observation concerning the circuit like this. What happens here is that the voltage here, the PDF rather, that comes here is the sum of the PDF here plus the one here plus the one here. So in series, the voltage is equal to the voltage of each resistors. What do I mean? VAB is equal to V1 plus V2 plus V3. So it is the algebraic sum. Algebraic sum. Sum of voltage in each. Same thing with R. Algebraic sum. So because of this, for R, the total R, that is effective R, is greater than the greatest resistor, resistance of the resistor. What does this mean? It means that by the time you get your effective resistance, it must be bigger than the biggest of the resistors in series. That is what this means. So when you are working and you realize that this total resistance you calculated is still smaller than the greatest, go back to your workings. That's what it means. So we have talked about the voltage and what we expect of the resistance. Another thing I want you to observe is this. The voltage here is proportional to the resistance here. You can see, because the I is constant. So if you have to get the voltage here, it must be proportional to the resistance here because the I is equal all through. Now, take note of this. We are going to resistors in parallel now. Now, let's look at how resistance in parallel is like. Now, look at this. The I that enters here is the same thing I that comes out at this place. But with the way it is arranged, VAB is equal along this place. So which means that V in R is equal to V in R1, sorry, is equal to V in R2, is equal to V in R3. You can see. So this I2, once it comes here, it divides. Unlike when it's in series, it flows like that all through. But once it comes here, just like a pipe of water, it will divide into this place. So we are going to have I1 here, I2 here, I3 here. You can see that's the main difference between resistors in parallel and resistors in series. So in this case, VAB is equal to VR1 is equal to VR2 is equal to VR3. You can see that is one. I is distributed among them in proportion to their resistance. So, and we know that IR is equal to V. Therefore, we can also say that VAB is equal to I1 R1, which is equal to I2 R2, is equal to I3 R3. And I is equal to I1 plus I2 plus I3. So by the time you look at it, you can easily say, okay, if I enters this circuit, the value of I that will go to R1, you can see it. The value of I that will go to R2, you can see it. And the value of I that will go to R3. How do you do that? You divide it using proportion. You divide it using proportion. Like this. R1 plus R2 plus R3. You know it. Once you have done that, you can now say, okay, I that will go into this one will be in certain proportion. I that will go into this one, you will know it. By using this one and by using this one, you can easily get it. So we can now see the main thing here is V is equal all through. I is distributed. In series, V is distributed. I is equal. Please take note of that. Another thing is by the time you add it, now let's look at how we can get our R now. You know that you have said that V is this. Now, let's look at this I now. I is equal to VAB over R effective. And at the same time, I is equal to V, this same V, over R1 plus VAB over R2 plus VAB over R3 is equal to VAB over R. Now, let's divide through by VAB. We are going to have 1 over R1 plus 1 over R2 plus 1 over R3 is equal to 1 over R effective of this circuit. You can see. So, if it is in series, you just add all through. If it is in parallel, you have to add the effective, you have to add the reciprocal of each to get the reciprocal of the R effective. It is after that you will now find the R effective by getting reciprocal of the answer here. Is that clear? We have gotten all this. So, note, the R effective must be smaller than the smallest resistance. For series, the R effective must be bigger than the biggest resistance. So those are the major differences. So when you are working and after doing it, you realize that your R effective is still a bit bigger than the smallest, resistance. Check your workings. Now let's try to see one or two scenarios of adding the resistance. Now let's look at this. In A, we have three resistors rather. 1, 2, 3 in series. Now join in parallel to 4. In B, we have 3 resistors in series. Join 3 resistors in parallel. Joined in series with 4. So let us calculate the effective resistance in each case. So in this place, the resistance of the series one here. So we have R in series is equal to 1 plus 2 plus 3. That is 6 ohms. So 6 ohms is in parallel with 4 ohms. So R 1 over R effective will be equal to 1 over 6 plus 1 over 4. That's 12. 2 plus 3. 5 over 12. So in this instance, R effective will be equal to 12 over 5 ohms. You can see. So in this case too, we have to take it one by one. Here, we have these 3 resistors in series. So, here we have these 3 resistors in parallel. So R effective of parallel resistors, we are going to have 1 over R effective of this will be 1 over 1 plus 1 over 2 plus 1 over 3. And that's going to give us 6. 6 plus 3 plus 2. 11 over 6. That's it. 6 plus 3 plus 2. 11 over 6. So R effective of parallel resistors is 1 over 11 over 6. 6 over 11. So we have that one to be 6 over 11, less than 1. Then R effective of the circuit will be equal to 4 plus 6 over 11 ohms, which is equal to 4, 6 over 11 ohms. So you can see, I just believe that with this, you can, differentiate between series and parallel. And at the end of the day, whenever you come across any of them, you'll be able to handle them effectively.